Hi, I'm Megan, and I'm going to be taking you through an advanced functions math question with a step-by-step explanation. By the end of this video, you will fully understand this problem. This question was taken from the Nelson Advanced Functions textbook on page 304, question number 7. It states, when polluted water begins to flow in an unpolluted pond, the concentration of the pollutant C in the pond at t minutes is modeled by CT equals 27T over 10,000 plus 3T, where C is measured in kilograms per cubic meter. Determine the rate at which the concentration is changing after A, 1 hour, and B, 1 day. So this question was taken from Unit 3, Rational Functions, as the equation that they give us is a rational function. It has a polynomial on both the denominator and numerator. First, let's point out the main concepts in this question. So the first one is T, which is in minutes, the equation, C in kilograms per cubic meter, rate, and the 2 times, 1 hour, and 1 day. Now let's go to our graph so that we can see the big picture. So this graph represents the concentrated of the unpolluted pond when polluted water is added using the equation given to us. As you can see, the horizontal axis represents the time, and the vertical axis represents the concentration. As you can see, as time increases, the concentration increases as well. These points represent 1 day and 1 hour. We will want to find the instantaneous rate of change at these points. In this scenario, we want to find the rate at which the concentration is changing. This means how much concentration of the unpolluted water is changing when the polluted water is added over time. Because this question specifically says rate, not average rate, we know that we are finding the instantaneous rate of change, or IROC. IROC is the exact rate of change of a function at a specific value of the independent variable. This is found using the estimated average rates of change for small intervals of the independent variable that are very close to the specific value. So let's go back to our graph and look at the IROCs for 1 hour and 1 day. The red line represents the instantaneous rate of change at 60 minutes. As you can see, the blue line represents the instantaneous rate of change at 1 day, or 1,440 minutes. As you can tell by the instantaneous rate of changes, the blue line is less steep than the red line, so we will be expecting a smaller slope for the time at 1 day. So now back to finding the IROC. There's 3 steps in finding the instantaneous rate of change. The first step is adding and subtracting 0.01 from the time that you want to find the IROC. So in this case, it would be 1 hour and 1 day. Then we will take those 2 times and plug them in to our equation. Lastly, we will take those 2 coordinates used in this equation to sub into the IROC formula, which is y2 minus y1 over x2 minus x1. And from this, you'll find the instantaneous rate of change. So let's start with the first question, the rate at which the concentration is changing at 1 hour. So first, since the time is in minutes, we need to know how many minutes are in 1 hour. So, as we know, there are 60 minutes in an hour. Now we have to do step 1 and take 0.01, subtract it and minus it from 60 minutes. Now we will plug these 2 numbers into our concentration formula, which is step 2. So once you plug the 2 numbers in, you should get a concentration of 0.15911 kilograms per cubic meter and 0.15916 kilograms per cubic meter. Now let's put these into coordinate form so it is easier to sub into our IROC equation. Now that we have our points, we know that this is x1 and this is y1, as well that this is x2 and this is y2. Now let's sub these 2 coordinates into our IROC equation. So our instantaneous rate of change after 1 hour should be 0.0026 kilograms per cubic meter. Now let's write a therefore statement. So therefore, the rate at which the concentration is changing after 1 hour is 0.0026 kilograms per cubic meter. Now let's check our graph to see if this answer is accurate. As you can see from where our 60 minutes is and where it is on the concentration level, it seems that our instantaneous rate of change is accurate to what the graph proves. Now let's go on to the second question. Now we are trying to find the instantaneous rate of change after 1 day. So we know that there are 60 minutes and 1 hour. And we also know that there are 24 hours in a day. So if we do 24 times 60, we will get 1,440 minutes. Now let's do question number 1 and add and subtract 0.01 to our new time. Now that we have our new times, we will take the two numbers and sub them into our equation. So you should get the two concentrations of 2.71507 kilograms per cubic meter and 2.715096 kilograms per cubic meter. Now let's put these into coordinate form so they are easier to plug into our IROC equation. By looking at these coordinates, we know that this is our x1, and this is our y1, and this is our x2, and our y2. Now let's take these two coordinates and sub them into our IROC equation. You should end up getting the rate at which the concentration is changing after 1 day, which is 0.0013 kilograms per cubic meter. Lastly, we just have to write our therefore statement. Therefore, the rate at which the concentration is changing after 1 day is 0.0013 kilograms per cubic meter. Now let's look at our graph to see if this is accurate. As we noticed before, the rate at which the concentration is changing after 1 hour is much steeper than the rate at which the concentration is changing after 1 day. So it does make sense that our instantaneous rate of change after 1 day was smaller than the instantaneous rate of change after 1 hour. A job that may have to solve a problem similar to this is a biologist. A biologist study living organisms often in the context of their own environment. Biologists involved in a fundamental research attempt to explore and further explain the underlying mechanisms that govern the functioning of organisms. Because this question has to do with polluted water, biologists need to calculate the rates of the water as the pollutants affect the living organisms. That is it for my lesson. Thank you for listening.